Is this thing on?
Okay, I want to talk a little bit about what AIRON's working on and what new solutions that we're bringing out to the marketplace before we get on to our next speaker and some of the reasons why. What you can see up on the screen here is a solution that we've worked on, that we've gone out to the marketplace and found different products and different controllers that are available to us. Ahmed mentioned that their next generation of controllers are going to be IP addressable. So this is gaining momentum. You're going to see it more and more, and we're already working with it in our own installations. And basically, what we've been working on initially, and we can see this getting basically being adopted through all elements of the marketplace, but where we see a specific market for it is in the small commercial building marketplace. And what we're terming this as BAS Lite. And the advantages of it is it provides the ability for us to do an extremely low cost installation. We can get easy access to it. It can be delivered as part of an ongoing service agreement, potentially a lease to own on the equipment or some rental agreement, or again, if the owner wants to capitalize it, he can do that as well. What it's going to get the end user is out of that reactive service platform or service manner in which we've talked about in previous mini seminars, and I'll build on that in a little bit, and move them into a proactive service monitoring environment. It'll allow for us to do energy analytics and dive it down to a very cost-effective manner, again, to the light commercial, potentially multiple building applications. We'll have energy analytics and fault detection working on this. It's extremely easy to install, and access to the system would be 24/7. So we'll get a little bit more into it here. So the way it would work, and the way that we've tested it to work, is basically we take a small building. A great example might be a car dealership. Typically, car dealerships might have 5 or 6 stores within a regional footprint. Specialty health stores are another opportunity, and it could go national as well. There's nothing stopping it from that. So looking at that type of a application, we might have a light commercial building. They typically have 4 or 5 rooftop units on them. Might have a couple unit heaters in the storage area, the warehouse area. If it's a car dealership, they might have some radiant tube heaters in the bays. And we need to connect all these things up. The problem we have in the retail market is they're notoriously short of capital to do any type of an upgrade. Jim Hickey's going to speak to you guys about some incentives, that would directly apply and directly help push some of these opportunities forward. The problem in the retail market is they may not be able to achieve the volume of energy dollars saved to obtain all the grant or incentive money that's available there. So we have to keep the cost down. So what we basically would do is take one of these I/O controllers that have a built-in IP address. We would attach a Wi-Fi router to it, and we could probably put that together. I don't want to oversell myself, but I think we could put one of these units together for under $1,000, fully installed. And then what we do is we basically drop these things on every rooftop unit that's in the building, and we might gather up a few unit heaters and radiant tube heaters, and so we can get these things installed within the equipment. Maybe 5, 6 I/O controllers would basically connect all the buildings up. We don't put a front end on it. We don't sell them a computer. We don't sell them a $5,000 software system. We don't have to do the installation. We don't have to do all the graphic build-up associated with that on site. In fact, we don't even put a network controller on this job. It doesn't need one. The network controller is basically the box that collects all the data and then moves it up to the server front end. Because these are all connected directly to the internet through a wireless router, we don't even have to pull Ethernet cable to these things. Every building on Earth now has an internet connection. So we don't have to provide an internet connection, we just piggyback onto that internet connection. Then what we do is we build one front end, and we put that on a server farm somewhere. And that one front end will support all the installations. It doesn't matter whether this guy's got 5 buildings or 1 building, and his neighbor has 5 buildings. It doesn't matter. One front end will support all the installations. And then we just subdivide the front end with username and passwords, and we segregate the graphics and the information that they have to use that. But we do that up here at our end. And once we connect those buildings to that single server, then all the applications that we have at that server level now become functional at the retail level. Energy analytics with fault detection. Bang, got it. Email alarm monitoring, sending service trucks out when something breaks out. Bang, they got it. And if we can keep this installation, depending on the site, under $25,000, the energy savings will offset the capital cost. We can convert that capital cost into a monthly service agreement, and we should be able to keep that commercial facility cash flow positive with an AIRON service agreement. So stay tuned. That's what we're working on. Go the other way. Both buttons, Tom, are sending me to the same slide.
Keep going ahead.
There we go. Energy analytics. I've talked about this before. This is where our R&D with Brock University is coming into. This energy analytics has existed for quite some time. Our challenge with energy analytics is, while the dashboards are great, and they can provide an energy manager very specific data as to how their building is performing, and they can look back on benchmarks and say, okay, this building's doing very well, this building's not doing very well. They can even normalize the building if it's a retail output for number of sales of all the widgets that they sell, and so they know idea how much store traffic is. They can normalize it to weather, and they can basically get a very good diagnostics or analysis of how that building is performing from an energy perspective. And that's great. But what it doesn't do is it doesn't tell them what's causing the deviation when one exists. And that's not good, because that can be almost like trying to find a needle in a haystack, because without having some form of fault detection, you have to have a person on site, and that problem has to replicate itself under a whole bunch of conditions before that problem can be discovered. And in many cases, it'll never be discovered. There's another problem with that. By the time you've done all that data analysis and you realize that you're wasting money, you've already wrote the check to Horizon Utilities and Union Gas, probably many checks. So that delay is what we call a reactive environment, and that's the world we all live in right now. We need to break that. This is a simple application. This is probably the simplest application of fault detection. And our good friend at Paul Quinn from Duke Realty, he actually applied this across 800 buildings in the U.S. It was his very first fault detection application, you know, from an energy analytics perspective. And all he simply did was, whoops, too many buttons here. All he simply did was connect to his meters, his house meters, to find out what was his usage on a daily basis. And then he went into we went to his facility management team, and he says, what's the schedule supposed to be of these buildings? Not the schedule that's programmed into the BAS. When are you open and when are you closed? Just tell it to me simple. So they told him that we're open at, let's say that's 7 a.m. and we're closed at, say, 5 a.m. So he put that data into his energy analytics program, and he pulled in his electrical data, And then he created a little bit of a little software process application that would compare the energy usage against what the suggested schedule should be. And wherever the profiles did match, he had some sparks generated, which are alarms. And so what he found and then up here he's got his energy, his weather data, which doesn't really apply so much to this application, but could apply to others. So he found out across I don't think he applied it to all 800 buildings initially. He applied it to maybe 3 or 4 and then expanded it. But what he found was that a significant amount of his buildings were not operating on their occupied-unoccupied schedule, and that was very easy to find because he could see that his energy usage was not properly aligned with when the stores or buildings are supposed to be open or closed. Really simple. But when you spread this out over a long period of time, or you try and find that after the fact, you've already wrote the checks. And this is where BAS Light Energy Analytics can provide the services that are required to obtain the payback out of the energy dollars to pay for the services. So I want to talk a little bit about cost of discovery. And this is all connected to how we do business today. In today's business, service business, if we're really proactive, we set up a service agreement with an HVAC contractor. That service agreement usually includes about 4 visits a year, which is once every 3 months. A technician comes along, does a complete check of the building. We all assume that they're experts and they're really into their job, that they don't watch Canadians play Ottawa into the wee hours of the night. They're and half asleep in the morning. They're all attentive and ready to go. And so they find the problems that exist within the building. They report it to the owner, and a procurement process is put in place to solve that problem. But often the problems don't even get found, or they're not easily found through just a walkthrough of the building. Or they occur the day after the service technician was there, and they stay there for the next 3 months until the service technician comes back. So you guys get what I'm talking about. We call that the cost of discovery. And it's the energy waste associated with a problem existing over a period of time undiscovered. Now that can do more than just waste energy. As is noted here, it can also contribute to the failure of other components in the building. Long-term damage. We've all come across dirty filter situation where it froze up a coil, and that frozen coil fed refrigerant back to a compressor and blew up the compressor. So a $5 dirty filter leads to a $5,000 repair to an air conditioning system. It happens all the time. So the idea being is, through the application of energy analytics, and potentially through BAS Light or through a fully installed automation system, is to apply an energy analytic system that doesn't only analyze the usage of that building and do the comparables, but it also has the ability to dive back into the system and find out what's causing the fault, and then send an email alarm. So you're getting these problems solved in real time. And in doing so, I'm going to have to come back a slide, you reduce your building maintenance costs, or not just maintenance costs, but your business service costs, capital costs, everything, down to the lowest common denominator, because through a proactive service contract, you eliminate the cost of discovery. You're finding out in real time, and you can directly go into the procurement process and get the problem repaired. Does everybody understand that? And what I find kind of surprising, because I've been in the HVAC business for 25 years, I've been selling building automation since 1994 and installing it, and the majority of automation systems that we install to this day, all the information sits in a computer that sits in an office that is 90% of the time shut off, and unless our BAS guys come to sign on to it and blow the dust off the monitor, it just sits there like a standalone system. So you have all this technology that's being installed at the cost of millions of dollars that's probably not getting more than about 3% of its functional use actually being used in the industry. Most of the systems that are installed today have the ability to connect the enterprise. They can send information out through the internet to a third party, but they're not being used. So although it would be easier for us to apply ANT technologies to AIRON installations because we would take that opportunity into consideration in our design, we also needed to say, okay, we have to take this a step further. We have to be able to perform the same functionality on systems that are installed by our competitors, systems that are locked down, that are proprietary, that you know, through our competitors, they're holding their customers hostage so they can't use the services of AIRON. And that's really where a lot of our R&D comes in with Brock University and our adoption of an energy analytics with fault detection tool. You know, and we're using SkyFoundry and the SkySpark platform in order to do that. And that basically is a layer of software that resides on top of the BAS system and can extract data out through the enterprise link that those BAS systems have to web services. Through the ability to do that, now we can cast a wider net and we can provide better solutions, and we will take, you know, their customers away from that hostage-taking environment where they can actually start to utilize a lot of the functionality of that system that up until now they haven't been able to, for one reason or another. So that's what's going on at AIRON, and I'm going to bring Jim Hickey up now. I think, hold on, this thing's, let me get it. See, I'm making sure you're getting the point here. Another thing before I bring up Jim Hickey, I missed this the last time, and this has gone through a lot of development since the last time we talked, and now it's a standard application that AIRON does in all our service agreements, whether the customer asks for it or not. And I know that's a bit bold of us because it's somewhat self-serving initially for us. And that's called Equipment Tracker. And what that is another database that we can access remotely at our servers. And what it does is it takes all our service files that sit in a drawer, collecting dust, waiting for someone to open to find out, you know, what the last problem was so that we can connect the last problem with the reason the text there again, and puts it all onto a server, makes it all available to every one of our techs via an iPhone. And again, it was initially developed as an internal tool, so that when we sent a technician to site and he's diagnosing a problem and he wants to find out what the last technician did, because that might help give him some clue as to where he should, you know, where he should go in his diagnostics, he would be able to bring that up right away. And we put this thing together, and the way we set it up was, all we did was hang some QR codes on every piece of equipment that we're looking after. And when our first round through the building, when we get a service agreement, we hang the tags. And then the first technician scans the tag and puts in all the critical details about that unit: model number, serial number, belt size, number of filters, type of filter, et cetera, whatever's relevant to that equipment, so that we can service it. Because I can tell you, I don't know how many times, and I used to be on the tools. I was a meter reader, remember. I ended up a service technician, and then I got this job. But I don't know how many times you go and you troubleshoot a unit, and you figure you got all the information you need. You go to the wholesaler, and it's that one part number that you didn't write down is the one they need to give you that OEM fan motor that you need so that the air conditioner will work. Of course, you get back in your truck, you drive all the way back to the roof, you go to write it down, and it turns out, well, the unit's been rained on for 10 years and that number's washed out, right? So now what? Right? You know, so we know about these kinds of challenges. Well, if we can get that data down as soon as we turn that building over, then we have it in our database, and we don't have to make that run back to the wholesaler or back to the site, which inadvertently is either going to be charged back to the customer, and what probably would happen, he's going to charge the customer because he wants to get paid. The customer is going to realize that that he had to go back and forth to site 2 or 3 times eventually, and he's going to call up me, and he's going to say, I'm not paying for that, right? And then I got to decide whether what am I going to do? Long-term customer, okay, I eat it, and I go, have a chat with the technician, and he's always got a real good reason why he needed 5 trips to wholesaler to solve the problem. And it's not all our technicians. These things happen. Trust me, it's not just AIRON. It happens to everybody out there. But nonetheless, so the idea that from an internal perspective, we wanted to solve that problem. And then what we found was that if we were to make this available to the customer and add a few additional features like running cost of repairs on the unit and what's been done, now what they have is a really slick asset management tool that they can start using not only to monitor the cost of their facilities and where the money's going, but they can also use it to try and determine where that equipment is in its life cycle costs. If it's costing them more and more money to repair it than it is time, then you get to the point where it might be worth investing in replacement.